Hi guys, today we're going to explore how we use substitution when taking indefinite integrals of trigonometric functions. So what we've got here is we've got a relatively complicated trigonometric function that we've been asked to integrate. So what I'm going to do first is I'm going to attempt to simplify this as best I can. The first thing that I always do is I look for these coefficients and I take them outside of the integral because we don't have to worry about them. So the first step, I think, with any integration problem that I do anyway, is I always take out the coefficient. So in this case, it's going to be 3 times the integral. Now I'm going to move the higher power trigonometric ratio to the front. So I'm going to have sine to the power of 4x. The power of 4x. And then I'm timesing that by cosine of x dx. Great, so now once we've got this is basically as far as we can go with taking out any kind of coefficient. So what we do now is we use the substitution method, or some people call it a U substitution. I just call it substitution because I don't use a U. So the next thing I do is I make a statement. I'm going to say let's A equal the sine of x. Now, the reason I'm doing this is because I can substitute out sine of x and I'm going to put in a, and then I'm going to integrate with respect to a. So what I'm going to have to do as well is we're going to have to substitute out this dx part as well. So the way we do that is we're going to differentiate a with respect to x that I've just, like in this function that I've just created. So I'm going to have dA dx. Now the derivative of sine of x is cosine of x. Cool. So the reason that we take this derivative here is because I can rearrange this, and this is the same with most substitution integral questions. I can rearrange this. I can move the dx, I can multiply both sides by dx, and I can divide both sides by cosine of x. So I can end up with the relationship d of x is equal to dA divided by cosine of x. Now, you're going to see in a second, but this is quite important in trying to simplify how we do the integral of this. So, now we're actually going to do the substitution, and we're going to substitute a in for sine, so we're going to pull that in there, and then this dx value that we've found, or this dx equation, we're going to substitute that in for dx there. So I'll change the color again. So post substitution, what we're going to have is we're going to be taking 3 times the integral of sine is now a, so it's now going to be, instead of sine to the power of 4, it's a to the power of 4 times by, we've got cosine x because we haven't been able to substitute that out. Cosine of x. Now instead of dx, we're substituting dA over cosine of x times dA over the cosine of x. Now hopefully it's easy to see that these two cosines of x will divide to give 1, so we can cancel them out. And we are left with, I'll just go back to the top. We are left with, this is going to be where the actual integral that we'll be taking will be 3 integral of a to the 4 dA. So, if we take this integral, we are left with 3 times, now let's put this in a square bracket, the integral of a to the 4, we add 1 to the power is a to the 5, then we're going to divide it by the power, so we're going to have times the integral, which is a to the 5 over 5 plus a constant, c. Now, you probably had everyone harping on about this to you, but make sure you put that plus c term in. There are so many people, I see so many people forget it, and they just lose marks for no reason, basically. Just put it in, it's easy to forget, but just remember that. So let's get rid of those square brackets. We are left with 3a to the power of 5 on 5 plus c. Now, we've just done our integral. Now what we can do is we can resubstitute our a back in. So that's all that we have to do. So we put a, the first time we substituted into the original. Now let's put it just back in there. So what we end up with, so this is going to be equal to 3 times the sine to the power of 5 of x divided by 5 plus c. So there we go. We've got once we do our various substitutions, taking the integral is not very difficult at all. But it's the method in which you do the substitutions which is sometimes the little tricky part to comprehend, I guess. So the first thing we did is we took out the coefficients. We then found the trigonometric ratio with the highest power and substituted that out for a letter. We then had to differentiate that letter with respect to x, so we could then substitute out the dx for the dA in this case. We then substituted back our two different things. We found that the cosine, or the other trigonometric ratios cancelled out. We had a very simple integral to take. Then we substituted the trigonometric ratios back in. So if you can follow that, it's quite simple when we finish up. So I hope that little explanation helped, and I'll see you again next time.